All right, welcome to the last day of the Dev Summit. I guess I'm always thankful for when anybody comes to one of my sessions, but when it's 8:30 on Friday, and I see some of you guys are bleary-eyed in the back, the coffee becomes more and more of a zombie crawl to the coffee as the days pass. So thanks for joining me. This talk is Building Apps with Esri Leaflet. My name is John Gravois. I got a ton of links to demos and examples and slides and snippets in here, so if you want to jot down the short link to the slide deck, that would be a pretty good idea. Not mandatory, but recommended. So today we're gonna talk. We got an hour. We're gonna talk about some of the fundamentals of Leaflet itself, some of the fundamentals of Esri Leaflet, introduce them, and dig into some depth. We're going to take a little cruise around the API to get familiar with some of the different classes when you might use them. I got some demos. We'll get like increasingly deep in the guts as we go through the hour, and then at the end we'll talk about some of the stuff we always like to sort of include in the talk, some comparison with the JavaScript API and contrast, and where we're at with tooling and you know where we stand. State of the Union's probably a little highfalutin, but I couldn't think of something better. So if you don't already know, Esri Leaflet is an open source project from Esri. I'm the maintainer of Esri Leaflet. It is the most popular project we have on GitHub. That doesn't necessarily mean it's the best, but the most people have clicked the little star in the top right-hand corner of the repo. I think we're like, let me look, I haven't looked at a while. I think we're like nearing 1,000 stars. And I've never tried to extrapolate and figure out how many developers that means are using the library, but there's quite a few out there. So we're happy about that. But it's not a product. This is not something that's sort of Esri's promoting. We're not selling it, obviously. We don't have a product lifecycle or an SLA for it. This is like real Wild West open source. You get all the benefits of digging in, but it's a real grassroots project. I'm the primary maintainer, but we have other folks from around Esri who've made contributions and are making contributions that come from professional services, from some other teams in core development, random sort of devs that work in tech marketing and have a need and spin up and do something with it. But everybody's kind of working based on their own needs. We've also got a lot of users consuming it happily, but we're also sort of actively seeking contributions from the user community. So it's a little different style product. There's a lot of good doc there. We're trying to be sort of clear about what Esri Leaflet is and what it isn't. This is all the stuff that I talked about, and I probably should have had this slide up while I was saying. But we'll talk more, obviously, about what Esri Leaflet is. How many of you guys already are using Esri Leaflet, developing apps with it? And it's like, this is kind of what I expect, is about half and half. So, and this is good. That's where I'm at with the talk. We're going to do some intro and setting expectations and level setting, and then we'll get into some deeper stuff too, and we'll try and get it all done. Leaflet, most people have heard about it at this point. Leaflet is an open source. I have a HTTPS link. There's no way that an open source project is going to pay for an SSL cert. It's just HTTP over there. Leaflet is an open source mapping library for JavaScript. It's not the only one. OpenLayers is another big open source mapping project, but Leaflet is the most popular one, and it's a more limited function set. There's less tools in there. It was written originally by a web developer who sort of didn't have any background in GIS and wanted to make it a lot easier for web developers to make maps. And the focus for Leaflet is to stay really small, to keep the performance good, to be really stable, to have a consistent API, and doing that and enabling an ecosystem around it has made Leaflet kind of become the de facto most popular library. So you see really big organizations using Leaflet, big organizations like Craigslist that I think have like 10 developers, but they ship, I can't remember how many page views a month Craigslist gets, but it's a gazillion. And then lots of one-off projects. You see people spinning up projects and using Leaflet. It's become, the open source library of choice. Just to kind of give you a real quick look, there, it'll come up. What I was saying before about being designed for web developers, all the geographers in the room will jump right out immediately and see that we're passing latitude and longitude when we set the center point of the map, which is YX. Man, this thing is going crazy again. Bear with me. Hopefully it'll quit. I've like tried to get my bearings here a couple times. I think it'll be okay. So YX order, it's controversial. There's going to be some of you in the room that are lat longers and some of you that are XYers. This is just a good example. I'm not an opinionated guy. There's no right or wrong answer to me, but this is kind of a hallmark of the notion that Leaflet's not designed for geographers. It's designed for web developers. They heard about lat long, so they pass YX. Something else that's really common in the Leaflet sort of paradigm is this notion of chaining methods together. So here we instantiate a map object and we pass the div on the page, and right off the back of that we hang a method call and set the view on that map. So this requires that this constructor passes back a reference to itself so that you can immediately call a method. It's something that's designed intentionally to make it possible to write really terse code. It's not something you have to take advantage of, and just as Leaflet was meant to introduce web developers to making maps, I got started, I didn't get started, but I got a lot of experience just programming in JavaScript, before I had a lot of experience. I came from the other end of the spectrum as a geographer. Learning how to write JavaScript, Leaflet was a good tool for me because there's a lot of simplicity in the tool set. It's not too expansive, so it's a little bit easier. And something that I'd recommend doing if you're still learning JavaScript especially is when you see samples or you're trying to do things yourself, not chaining a bunch of methods together is a good way to help the code make more sense and do one step at a time. If you set a breakpoint and you do one thing at a time, you have a lot better success debugging than if you have one line of code that chains 4 different methods together and comes out the other end. So Leaflet is, I keep saying it's small. How small is small? 36 KBs across the wire. Gzipped is about the same size as one 256 PNG map tile. So that's really small, and small is really good especially for open source developers. They like that high performance. They want to have the app load initially as quickly as possible. So small is good, but small also has a consequence in that you can't be small and do everything at the same time. So if you want to put some data in a Leaflet map, theoretically you're going to have to at least get some data somewhere somehow. So GeoJSON is the standard currency in Leaflet. If you have just a flat file next to your HTTP, your HTML page that's got GeoJSON in it, and you want to fetch that, one would think you might just be able to fetch that with Leaflet. That doesn't seem like a real burden, but you can't. You either need to deal with it yourself, figure out how to make an XML HTTP request, or an AJAX request, or use fetch or something, or you use a plugin to help. So here's an example. Somebody wrote a plugin for Leaflet that extends l.geojson with a new AJAX method that lets you just provide the URL to your GeoJSON, and then when you get it back, add it to the map. So you have to load a plugin. I would say this is pretty much getting started territory. But this is intentional in the Leaflet world because it's not because this kind of thing is not important enough, but the design of Leaflet is giving a lot of power to the developer to do things the way they want to do them. And if you're using jQuery with your Leaflet app and I'm using something else, theoretically something's gonna give me the functionality I need to make AJAX requests. So Leaflet's not opinionated. It sort of assumes that you're gonna bring all that stuff to the table yourself. That's just the way it works. It's a lot different than the JavaScript API in that way. The good news is Leaflet has a really big plugin community. This notion, this is like I think it's a Unix thing originally, this notion of do one thing and do it really well. Grab all the pieces and put them together, make your own Lego set. That's the design of Leaflet, and it's been really popular. A lot of people have extended Leaflet and commercialized it or just used it for their own purposes, but a subset of those people have open sourced their plugins that extended Leaflet the way that they needed to extend it. So you can plug and play or mix and match a bunch of different plugins without having to write all the code yourself. You just have to make them talk to each other. And Esri Leaflet is our plugin. It's actually a collection of plugins, but Esri Leaflet itself is a plugin for sort of taking all of this rich content that's in the ArcGIS ecosystem, whether it's ArcGIS Online or ArcGIS Enterprise, and drawing that and displaying it and visualizing it in Leaflet and making it really easy to do. So Esri Leaflet's not a fork of Leaflet or an alternative. It's something that sits on top. It's a plugin and something you can mix and match with other plugins. Our goals with Esri Leaflet, these are the three most important ones. One, we want to provide some sensible defaults. We want to make it as simple and straightforward to use. We don't want you to have to make decisions when you're doing the most common thing. We want it to just work. We want to mimic Leaflet's own conventions. We want to make programming Esri Leaflet look and feel as similar as possible to Leaflet. And some plugins, I think, do a better job of this than others. And we want to keep it simple. So the consequence of that is we don't touch every last nook and cranny of the ArcGIS ecosystem. We just deal with the most popular service types. Doesn't mean that you can't extend Esri Leaflet if you have a niche requirement, but it's something that you're probably going to do on your own. So we'll take a tour. And I came up with this one. This has been my last talk, but I think this works pretty well to sort of draw some parallels and talk about how Leaflet works. So without Esri Leaflet, a simple map here, I showed you how you make a map before, and now we'll talk about how we add a layer to the map. For a tile layer, a generic tile layer in Leaflet, this is when you've got a cached map service. So you could use an Esri version of this would be a map service that's a tiled server. In other open source tools, there's like TileMill and some other things that you can use to generate tile sets. This convention of having Z, Y, and X to denote the grid of a Web Mercator tile set. In Leaflet, you have to know what that URL syntax looks like. And to be a good steward, you have to do the attribution yourself. You have to know how to attribute where you got the data from. And you add the layer to the map. But it's pretty straightforward. Leaflet itself has both a small CSS library that helps you style the map and a JS library. Those are your only dependencies and you're good to go. Leaflet doesn't depend on anything else. For Esri Leaflet, we still got to load those Leaflet dependencies. Then we load Esri Leaflet, and you can pull this from a CDN and let us host it, or you can bundle it with your own application. But then we just get a one-liner. For the most common Esri basemaps, we don't want you to have to know what the URL is. We don't want you to have to provide the attribution on your own. I mean, not to say that you can't do that, and some people sort of make Leaflet applications that do. But if you take a look here and I zoom into, say, like the San Francisco area, you can see that attribution here in Leaflet's control, it updates automatically as I pan and zoom around, because Esri's base maps, it's not all our data. We've got a community maps program for data contributors. We're getting data from a bunch of commercial providers. And in San Francisco, the data is different than somewhere else. So Esri Leaflet sort of cleverly or smartly under the hood does the attribution for you. In your location, it's going to just work and be dynamic, and you don't have to write any of that code yourself. You don't have to know what the URLs are or anything else. We've got a handful of Esri hosted base maps, and we can add them with a one-liner. We can also get in there and provide some constructor options. And this is an example. Actually, I must not have actually implemented it here in my snippet on the right. The minimum, yeah, that's okay. If I wanted to constrain the extent of the map or not let folks zoom in, oh no, it's how far I can zoom out, right? Yeah, there we go. Forgot, this is a classic geographer. What minimum zoom and maximum zoom, small scale and large scale. In this sample, I'm constraining the map. I'm not letting people zoom out any further than level 3. And this is a constructor option that comes from Leaflet itself. So in Esri Leaflet, we've got a basemap layer, and it extends the tile layer that I showed you before. So we've got some special sugar, little syntax, and helpful bits, but you're also there, get all of the options that are available in Leaflet itself by virtue of us extending an inherent Leaflet class. So and fundamentals, we talked about the tile layers, we talked a little bit about GeoJSON. When you're ready to work with some GeoJSON in Esri Leaflet, you either fetch it from a static data set or you have it right there inline in your application. You have either one feature or a big collection of features. Leaflet has a built-in object, the GeoJSON object, that you can pass this raw JSON object literal to, and then you can bind a pop-up to it, and you can dig into the properties of the data and bind a pop-up really easily. And people, the bare minimum for a mapping library is to have dots on the map. But this is relatively straightforward to do with GeoJSON. What we do with Esri Leaflet is build on those same fundamentals, follow those same patterns, use that same style. Give this thing I'm probably on the wrong Wi-Fi network too. Refresh here. There we go. With a feature layer, when you've got data in an Esri service, whether it's hosted ArcGIS Online service or ArcGIS Enterprise, you've already got that data published and you've got a URL for it, and you're pointing at a specific layer. You can create a new Esri feature layer, pass us the URL. At a minimum, all you need is the URL, and then add it to the map in the same way. And what we're doing under the hood is any new-ish version of ArcGIS Enterprise, and certainly ArcGIS Online, they know how to emit GeoJSON natively. So in that case, it's great. We can just ask for GeoJSON and get it. But we know some of you guys are working either in an organization that's working with a little bit older version of ArcGIS Server, or you might be making an application and pointing at a data set that somebody else maintains on an older server. So under the hood, Esri Leaflet determines whether or not it can get GeoJSON, and if it can't get GeoJSON, it gets regular Esri JSON, parses it and converts it, and then gives it to the Leaflet application as GeoJSON. And that's all details that there's going to be a rare few of you that are interested in the details of how that works. I'm one of those people, unfortunately, but we'll talk about it a little bit later. But in general, you don't have to worry about it. We also do browser caching, so we break up the current map extent into a dependable grid, so that when we query and fetch those data sets, we can take advantage of just caching that's built into the browser. So all that logic is built in under the hood, and it's simple here up front. And we bind a pop-up the same way. Here we've got a GeoJSON, so we could set a breakpoint in there and set our pop-up with the properties from the GeoJSON content that's coming from an Esri service. So tiled map layers, this is another kind of one of the core objects in Esri Leaflet. Most of the time, we're thinking that you're probably able to use Esri's hosted feature or map services, cache services as the base map. But some of you guys, I'm sure, work at an organization that's big enough or has enough complex architecture where you're making your own base maps. So tiling those base maps, it's very more or less exactly the same as our base map. You just provide the URL to where this has to be a cached map service to work with tiled map layer. And the caveat here is, because Leaflet's small, Leaflet assumes that the world is Web Mercator. And we've seen a bunch of examples where we use lat long. So this is an abstraction. The Leaflet map by default is always Web Mercator. So the coordinates that are really being displayed are northings and eastings in meters. But that's hidden from the developer. You just think about WJS84, latitude and longitude, and WJS84 GeoJSON, and everything just works. If you have custom projections, which I'm sure some of you do, you're on the hook to make sure that that's going to work. We've got some code examples, but you're already adding extra code to do that crazy thing, like make a web application in another projection. So this is another example of a consequence of Leaflet being small is that it doesn't handle all those things for you the same way the JavaScript API does. So dynamic map layer, I think this is like more my problem in refreshing. I'm also working with some sample services that are don't have an SLA behind them either. I'll just talk about it and then hopefully it'll come up. So if you have a map service, you want to fetch an image from the server. There it goes. You want to fetch an image from the server and you haven't cached it. You know, we always recommend caching to speed up performance, but there's a lot of there are situations where you wouldn't cache a map service because because the data is changing behind the scenes very, very frequently. So if people are making updates all the time. Two, if you need to get some more control over exactly what that map looks like. So here's an example where we point at a map service. This is the same kind of URL as a map service that might be cached, but this one's not. But in this case, I'm passing a layer definition to say, when it comes to layer 0 in that map service, don't show me all the cities. Just show them to me if they've got a population above a certain threshold. So I can manipulate, pass a few extra parameters to the service and manipulate that response. But the benefit here, the difference here is we're not fetching data, the real JSON. We can't sort of interact with those graphics. This is just an image that comes from the map service. And this is something that's been around for a long time, and in a lot of situations it's the right thing to do to display the map and get the best performance instead of loading down the browser with too many features that you don't really need the user to interact with. And you can bind pop-ups as well, and what happens when you bind the pop-up is there's a small delay. We fire off another request and then we actually identify some features. So we don't have that seamless interaction where even just panning over a feature is able to display the pop-up, but you can interact with the data. So it's not an either or. It's just sort of a different paradigm. Image map layers. Any of you guys work for an organization that publishes image services to ArcGIS Enterprise? Got a handful, not too many, but image service is fairly similar to the two before, but the benefit of an image service is, I only took one remote sensing class in geography in college, but this notion that images are not just what we can see in red, green, and blue, like satellites like Landsat and these others. They're collecting information in the electromagnetic spectrum in multiple bands, some that we can see and some that we can't see. So really sort of rich imagery can have information in multiple bands, and we can also manipulate to make it look like it is going to give us some more information. So some of the examples of this are like when you're doing vegetation studies, you want to look at what's in the near infrared to see what the health of the crops look like. So it looks much the same in Esri Leaflet. We pass the URL of the image service, but as long as the service supports it, we can ask for a specific combination of bands. We can ask for a specific time range. So one image service can be hosting data that lets us go back through different slices of time. And there's even this concept of what we call custom raster functions, where we don't just display the raw bands, but we do some math on the bands to get them to sort of provide some more insight. So here's an example with some custom raster functions, and something like NDVI colorized is, one band added to another and divided by a combination of the other two, and this gives us something that looks really crazy. But in this kind of a map, dark green is the most vigorous vegetation, and brown is the most sparse vegetation. And it's a lot easier to see this than just looking at a natural image. We got a whole bunch more Esri Leaflet plugins. That's all the stuff I showed so far is built into Esri Leaflet. But there's a collection of plugins, and we made an intentional decision to not trying to wrap up everything all into one library, because we knew some folks would want to use some stuff and others wouldn't want to use it, so we wanted to follow that leaflet pattern. So we've got a whole bunch of other plugins. You can look here on the Esri Leaflet webpage. There's some that we've written, some that we've written and collaborated on with customers, and there's a few really good ones that customers have written. and you can check out some examples and see how they pair. The kind of primary, one of my favorites and one that's really popular is this geocoding control. So this, if you want to have address search in your application and you want to have, people start typing and get suggestions and then zoom to a location, this is a plugin. So you add it on top. If we look at the code sample here, we've got Leaflet and it's CSS and JavaScript. Then we load Esri Leaflet. Then we've got the geocoder and its CSS as another dependency. So you start adding them all together in order to extend it. So this stuff is all just Esri Leaflet on its own, and then we make the search control. And that's an extensible plugin you can use. Obviously, it uses our world geocoding service by default. That's got points of interest all over the world and addresses data. That's really rich in different places. But you can also pass in your own services. So if you want to search on your own feature service so people can get suggestions, start typing, and find one of your features, you can extend it to do that. Another one that's kind of a surprise to folks, when you publish an Esri service, that layer, you're usually defining the symbology, and the service itself publicizes how it should be symbolized. And in Leaflet, we don't take advantage, in Esri Leaflet, we don't take advantage of that by default. We have another plugin that says, if you actually want to render it, I could see it on my screen too. Let me unplug and plug in again. But if you want to symbolize based on what the service is telling you, you just have to add that extra plugin. And a lot of folks, it's just how much we're teasing out things that you may or may not want to do, for better or worse. There's also geoprocessing services. So this is like an extensibility point in ArcGIS Enterprise for whatever kind of custom analysis you want to do. And we've got a plugin for that. I'll show some examples of that here next. Hopefully the display will stick with me. I'm doing okay on time. More Esri Leaflet plugins that you might want to check out. If you're doing driving directions, we've got a plugin, and that actually dips into some other just plain Leaflet plugins and works together. There's a demo here. I got links to all this stuff in the slides, but this shows an example of how it's implemented. Again, by default, we just use Esri's hosted international routing service. And you can drag a point from A to B. You can add another mid-stop. You can see what the directions look like. And I've got an example here that has users sign in to do it, because this is something you got to pass a token to, and I think you have to pay us like 3 cents every time you do this. Or you can have the app authenticate. So that's something that's interesting. Streamlayers is a plugin that was written actually by not somebody at Esri. It's a developer that's down in Australia. So if you're working with GeoEvent server and you've got WebSocket enabled layers and you want to display that on the map, this is an example that's taken live data from buses in Los Angeles and displaying those on the map. There's a plugin for that too. Web maps, if you're making maps in ArcGIS Online and you want to make an application that reads and displays the web map via its ID, that's in another plugin. One for legends as well. We got a whole bunch. This is kind of something that I don't think happened by accident. I've been thinking about this for a long time. I checked last night, having 61 different contributors. The bulk of these contributors to Esri Leaflet are, at this point, not Esri employees. So over the last couple of years, I've been thinking really hard about how to make sure. My pet peeve is, there's a lot of open source projects out there that are, I would call, hostile or just not really trying to be sort of growing their community. They're like reluctantly open source, or I don't know, they open source with a chip on their shoulder. So, I've always thought really hard about making sure that the Esri Leaflet repo is a place where people feel welcome. You can ask questions and get help from somebody else, and that somehow has turned into folks that have pitched in and made contributions. And a lot of cases in the last year, I've had folks propose a new feature, and I've been able to work with them and help them land the new feature that they wanted to see. They were actually able to contribute it themselves and then see it appear in another release. So that's, you could call it lazy, but it actually takes time to do it. So, and it's fun to do. I really like doing it. So if you're interested in, becoming an open source contributor, whether you have experience with it already or not, this is a good place where you might be able to do it. I'm going to highlight some of the contributions, some improvements to Esri Leaflet that customers have made over the last year. Some of them have been bug fixes. Some have been bug fixes that fixed bugs that were my fault. Some of them weren't. How many of you guys have heard of Clarity World Imagery? So this is, we had a release in, we're always have a cadence to our release of, bear with me. There we go. We always have a cadence to our world imagery updates. Everybody, for the most part, wants the newest and latest and greatest imagery all the time. And we're adding higher resolution, newer imagery in the US and Europe and across the globe. Every couple of months we have an update. And we've got like a half a dozen commercial data providers, and we've got, I don't know how many contributors to our community maps program. Some really fantastic imagery. But there are locations where the more current imagery is, for some folks, not as appealing as imagery that they found before. So Clarity is an alternative tiled map service layer that prioritizes clarity is the word they gave for it. So a lack of cloud cover and actual accuracy on the ground over currency. So if you're working in an area that hasn't had a bunch of construction in the last year or two, you might actually be benefited by using this alternative layer. And so it was publicized. It's been around for a while, but it was publicized a couple of months ago, and somebody wanted to see an Esri Leaflet, so we helped land this feature. And here's an example. Lo and behold, of course, near Seattle, you've got all these clouds in our new imagery. It's not too bad, but it's a little bit obscuring. And you can go back and look at Clarity, and Clarity's a couple years older, but it's, absolutely no cloud cover. So they're curating with a different set of priorities in mind, and it's something that you might want to take advantage of. And it was a cool improvement to Esri Leaflet that was pretty straightforward port and code. Finnegan is somebody that works at the city of Boston that we rewrote all the code in ES6 a long time ago, and she caught the last couple of places in the code where we weren't actually using ES6. We were just digging straight into Leaflet's global namespace instead of getting an ES6 import, and fixed all that, which was appreciated. Spoil Sport Motors, which is a pretty rock solid GitHub handle, recently caught a bug where if you have a tiled map service that requires authentication and you want the app to authenticate, so you set up a proxy bit of middleware to make sure that all worked right. He caught a bug in that. Jeremy Folds added a new method on query to make sure that they could return that M value. So some people are working with feature services that have linear referencing coordinates in addition to just X and Y or X, Y, and Z. So he added that. Joe London added another one to query where he wanted to only fetch distinct matches. He didn't want to have any duplicate attributes in the response. Bling had support for, we only used to support dropping a point and identifying features with a point and a tolerance. And he wanted to draw polygons and figure out which features intersected with that through identify. So he added that. We got Skaden doing polar projections, working on something at the North Pole, and wanted to see dynamic map services at the pole and a custom projection. Better error handling for image services and dynamic map services. It's a whole bunch. I think I got a sample here. Just to show you, give you an example of how involved some of these fixes were. I've got here in query, I'll look at the history, and here's Jeremy's commit to add that new feature, and that was a rock solid one line of code. We've got a utility method that adds the setters, and so it creates a new method using this name and value pair. But knowing where that was, shipping that, rebuilding it, like it adds a new feature. So a lot of these things are actually a lot more straightforward than you might think. Another key goal or design agenda that we've had in the last, I'd say it's probably going back 2 years now, is to really tease out the dependencies and the way that Esri Leaflet works and the way a lot of other Esri projects work and open source projects work, to create atomic modules that are as universally useful as possible. So a good example of this is In Esri Leaflet, sometimes we need to take Esri flavored JSON and make it look like GeoJSon. And the example at the top, the one at the top is Esri JSON, the one at the bottom is GeoJSon. To translate back and forth between the two is, usually it's not that hard to do, but you get situations where you have like polygons with donut holes with different ring winding order. Or there are gotchas and things that make this kind of tough. And it's not just Esri Leaflet that needs to do this. So extracting that logic and putting it in its own JavaScript module that anybody else can use. We use this in another popular open source project called Coop. I've seen this used in, we're working on a new integration in OpenStreetMap to do some editing in OpenStreetMap. It gets used there. So if it's not just a Leaflet thing, I mean, Leaflet's popular, but not everybody uses Leaflet. If it's designed in a way that's like really vanilla, it becomes a lot more useful. You get more people using it, and then they catch little bugs in it, and it becomes more and more bulletproof, and then everybody benefits from it. So we've been doing a lot of that kind of refactoring that you don't see a lot of benefit from it sort of it doesn't always bubble up to the surface of the API, but it ends up being, still useful in other ways. Some other examples for the way that we do our gridded queries to take advantage of browser caching. This is something that was designed as just a core Leaflet dependency that other Leaflet plugin developers could use. So breaking up into that grid and firing off events when that cell is part of the map or not. Another one is just a small binary search that helps us look up the value. So once we've got a feature cached and in the browser and we want to fetch, go in and into that object and dig it out. This is something that we designed in a way that was really sort of generic and not just Leaflet inspired. But we've been working really hard on that. Another one I don't have a slide for is a project that we just started called ArcGIS Rest GIS. And this is just making the low-level requests to the REST services. And we've got a new, it makes Leaflet seem huge. It's only like 900 bytes. It's really, really small. It doesn't do a lot. And we're in the middle of porting Esri Leaflet to use that library instead of rolling its own implementation of request. So let's take a look at a couple of demos that you probably haven't seen before. Just keeping track of time. So I've always found it really fascinating, like the routing services. Not everybody uses these, but these are cool services that Esri hosts that do, I think, a lot more, they add a lot more interesting bits than just driving directions from here to there. So finding the closest facility is another Esri routing service that's hosted. You don't even have to have any data. You can just use this. I guess I also gravitate to these because I don't want to publish my own services. But this is an example where I'm pulling down in Long Beach hospital data from their open data site. So I'm fetching down that GeoJSon for all the hospitals and plotting those on the map. And then clicking on the map is a simulation of saying if a 911 call comes in and the ambulance goes to the scene and somebody's hurt, they don't need to know how to get to the hospital. They need to figure out which of the hospitals is actually the closest. And so these services basically do some more route solving and then figure out, based on even current traffic conditions, which is the appropriate destination to go to. So like I showed you before, this is basically a custom GP service. And the way it looks under the hood, if we set up, let me blow this code up a little bit. All right, so this is just a one-page app. Like I said before, we load Leaflet, we load Esri Leaflet, and then I've got this GP service that I was telling you about. There's a plugin for that in Esri Leaflet that you can fetch down from the CDN. I'm also using another low-level project that we open sourced. If you want to do just dots or crosses or circles or triangles or some of these common shapes to symbolize your features, we publish some shape markers. These are just SVG and can be reused. So those are just generically useful in Leaflet. Here I start my map, and for some reason I'm going down to like the molecular level of my initial starting point and set my base map. I've got some empty groups where I'm gonna draw my eventual content. So I've got the routes and the ambulance. So I'm not drawing those initially. I add them to the map with no data in them. The ambulance icon, this is a leaflet convention of defining an icon that's fetched from an HTTP resource. I found a PNG. And at that point, I've got all the icons set up, but I haven't drawn anything yet. The closest facility service, here I'm pointing at Esri's service for determining the closest facility. And this is a URL. I don't know if you've seen these before. There's some examples, or if you look in the code here, you can see a link to the documentation. This is a cool service because it's proxying a service that requires authentication. You can set up some of the configuration parameters, and then you can use the service without doing authentication every time. And then I just get billed that 2 cents every time I do this presentation. I tell them to take it out of my paycheck. So you can set those up too. I think they're a fun way to do it. So here I set a couple parameters on this task, and this like, you have to look at the REST documentation for the service when you're doing stuff in Leaflet like this. But restricting, you know, if I want to set some additional parameters to like not allow U-turns, or I need to approach on the left side of the street, all these services have really fine-grained control over how you're able to use them. So here I say, I'm driving an emergency vehicle, and this allows me to like go the wrong way down a street, or do something in traffic, or have different weight associated with my travel time than anybody else. So this is a good example of like how coolly fine-grained the axis of control is in some of these Esri services. And I want those routes back. So that I'm just setting up those are all just setting the stage for later. I still don't have any information yet, right? First, I've got to actually get some hospitals, and that requires another browser request. So I'm going to do, instead of doing a feature layer, I just fire off a query. So I point at the hospitals. I say, within the map bounds, just grab me one time all of these hospitals all at once. I don't want to do this browser caching and fetching as I pan around. This is an isolated area. And here I'm doing chaining the methods together. So it's, if you're familiar with promises, we're not using promises here. This query and then within, chaining those methods together, those are both synchronous. They happen in a synchronous way. This run, here's when I finally get into some asynchronous happenings. And this is a callback. And I don't know if you guys, some of you may have written some code in Node and some of you may haven't. Before, promises were cool. This notion of a callback and expecting the error to come back in the first argument position, that's like a node signature style that we use. But basically what we're doing here is waiting for the response to come back. When it comes back, then we finally execute this code block. And I take this GeoJSON and add it to the map, and I use this cross marker to use a red X for the hospitals. And then I can set that parameter up for the routing service to say, the destinations that I want you to consider are these hospitals. I couldn't do it right off the bat. I had to wait for them to come back in the response. Then I wire up an event listener. When somebody clicks on the map, then I need to clear anything that happened before if somebody's already run this. I add the ambulance to the map so people can see it. Then I set the parameter of, for closest facility, it's incidents and facilities. The facilities are the destinations and the incidents are the origins. And I run that task. And once that response comes back, I add it to the map. And this is just the GeoJSON polyline. And that's it. It's like 100 lines of code. So we're hitting a custom GP service. The routing service is just one of many GP services. We've got them for analysis, watershed, there's all kinds of other things. The point of showing you the sample is, one, I think it's cool, just to show that you can kind of do anything you want. But two, to be honest about the fact that you have to go in and look at the REST doc and make all this work yourself. We've got good documentation, but it's not all wrapped up really in the Esri Leaflet documentation. We're just going to assume you're going to go to another source for it. We got another one of the traveling salesman. This is sort of this common problem of not just routing from point A to point B, not just asking one origin which destination it wants to go to. This is pass a whole collection of origins and destinations and stops and distribute the stops amongst the whole fleet. So in this example, I'm just using a couple because more than that would be overwhelming. But this is a depot in San Francisco and a collection of stops to make deliveries. And we're optimizing, one, we have to distribute the stops amongst both the drivers so they drive as little as possible. But two, we need to make sure that they, you can set a weight limit or a size limit so you won't fill up a truck with too many packages, more than it's allowed to make. You can also set time windows, like, say a driver's not allowed to drive more than 7 hours in a day or 8 hours in a day. You set a bunch of restrictions and then do this route. And there's sync examples of this and async examples. And this is pretty similar. I'm not going to spend as much time on the code, but we load in pretty much the same prerequisites, point at another proxied service, set up some parameters that are static from the very beginning. The orders are the packages. And this time I'm just actually fetching them. I put them in a Geo JSON file right next to my application. And then I fire off the response. And then when the result comes back, it gives me back an array of routes. And I just filter and call truck 1 red and truck 2 purple. And that's it to display it. So this is like another example. You could build more of a UI around this, but just wanted to show another example of something that you wouldn't see just in the doc page. Okay, my last one. We're doing okay on time. The last one's Lurk. Has anybody heard of Lurk? So Lurk's another open source project of Esri. I do a lot of I don't know what you'd call it, like consulting, or I help other teams sometimes open source their work. This is a bunch of code that is way over my head. This is like low level C++ code. Lurk is something that the engineers at Esri worked on. This is a project that they did with NASA and NOAA. And it's a compression format for rasters. So I'm sure you've heard of like PNGs before. So this notion of compressing and getting a small file type output out of an original image without sacrificing quality that much. Lurk is not better than PNG because it gets smaller file output than PNG does. The cool thing about Lurk is you can control how much precision you want to retain. So you can make a Lurk compressed file that really preserves that integrity of the original image. And the performance when you decode and encode is really, really fast, like faster than any of these other image formats that are out there. So the cool thing is you can store your authoritative data with really high precision. And then in the context of the browser or something else, you can decode it, get the accuracy or the precision that you need, and do all that client side. And that's like opens up a lot of new possibilities. So Lurk is its own open source project. It's got nothing to do with Leaflet, with the exception that there's an encoder in C++ and then a decoder in Python, JavaScript, and C#. So I wanted to use this in Leaflet because I thought it'd be fun. Our world elevation service is published with Lurk tiles. And this is drawing those Lurk tiles in a Leaflet application. And this is a bit of a, I don't know if it's fair or not. This doesn't use Esri Leaflet. This is just another custom Leaflet plugin that uses another open source Esri thing. I think the reason I'm showing it is because you can use it. It's open source. It's just another example. And it's built with the same exact pattern. So this is world imagery. This is the same content when you see like a JavaScript API application and it's 3D and then they drape like over the terrain, make it actually look realistic. This is the same exact data and they're parsing it the same exact way. And the cool thing here is I can filter, like I told you before, I can manipulate this client side. So if I go to say, here over in Spain, and at first, I from black to white, I stretched out everything so everybody could see like all the way to the Himalayas. But if I'm here and I zoom in really close and I want to see what the elevation looks like, some of this, it looks like a DEM, I can filter that and get some more resolution, and I can dig right into the actual raw pixel data, right, all here in Leaflet. And it's not a tremendous amount of code. So I'll show you how this is designed. So I've got index, so Lurk layer is a custom, I just made another custom layer type for Leaflet that Leaflet had never heard about before. And I'm extending grid layer. And this is a generic layer that fetches data from a grid. So tile layer with tiled map services is built the same exact way. But before I get into that, I'll show you the index. So here we load Leaflet and its CSS. We load Esri Leaflet. Oh, the reason I did stick Esri Leaflet here just for the address search. So if we want to search for Palm Springs, Leaflet will help us with that. Then I've got Lurk. So I'm fetching Lurk from unpackage.com. Unpackage is a CDN that hosts content that's on NPM. So NPM is like the most popular package manager for JavaScript. People are using it for Node projects, but also for more and more browser projects. This is something that we published as a UMD module so that you could use it anywhere. It's a really simple API. The code, I could not come close to comprehending what's inside this library, but to external developers, all we're exposing is one method that's decode. So you go from a binary, compressed, unintelligible file to, tile of Lurk information to an array that you could actually work with in native JavaScript. So that's something you could use anywhere else. We're back to the browser here. I load that as a dependency, and then I've got my little slider. I just found some other open source project for that, so I wouldn't have to build the UI myself. So here I set up the slider and its values at the ends and what the range is going to be and what a step's going to look like. When people set it, I'm going to actually do something to the Lurk tiles and filter them and make them look different. But for the most part, I just constrain the map with some bounds, northwest and southwest, northeast and southwest. I make a map, and then I make this new Lurk layer. So here's an example of a layer, an object type. It's not in Leaflet, it's not in Esri Leaflet. It's a Lurk layer. This is custom. And all I'm saying is no wrap is true, so I don't make the map go around and around the date line. I got some static attribution, and the tile size is 256 pixels. The Lurk layer here, this code that's on the side, this is the plugin. And this is only like 50 lines of code. Extending grid layer. Grid layer is a generic thing in Leaflet, and when you want to have a custom grid layer, you need to let it know what happens when you create each tile and how you draw each tile, and that's it. So what we do with the Lurk tiles is, because they're raw array buffers, even when we decode it, this is actual raw array, I have to make my own XML HTTP request. Leaflet's not helping me with this, and I don't have any other sort of plugins or libraries. So I fetch the elevation tile, and here I have to know what the URL looks like. In create tile, it's passing me back the coordinates as the first argument back. That says for each tile, I'll tell you the zoom level and the X and Y in this grid. And I'll use that to construct to figure out what the URL is for that tile. Then I fire off the request. I check the status response. You might have seen this before. You could, if I wrote this today, I'd probably use fetch or something else, but that's fine. And then when I've got the response back, then I call Lurk decode. So this is when I use that NPM module. With the response, I get the decoded pixels. Now that I have the decoded pixels, I can draw them. And here they had a little code sample in the GitHub repo, and this is using the canvas. So they did this thing on purpose where they overlap the tiles by one to make sure that there's no overlap at the date line. So I trim off that. It's really a 257 pixel tile. And set up a new canvas context. This is like low level, so canvas and SVG are the way things work. And I plugged in the code that they had in the other repo to mask those images, and then I draw it. And I call draw again later on when people pass a new value here in the slider. I just call draw again with different values. So it's a fun sample. It's kind of, I like doing it because I think about this thing. This is like open source top to bottom. Lurk is an open source project, open source content in an open source API. So this is mad cred on the open source scale. Okay, we got 7 minutes for this. I'll save a couple minutes for Q&A, but I think I'll lead into this with, people have asked me in the hall a couple times, like, where we're at, what now? So Leaflet has pushed a couple releases and bumped the minor version. I mean, I can't speak for Leaflet, but I think that it's going to be unlikely that we'll see a Leaflet 2.0, maybe ever. It's possible, but based on the trajectory of the development, we've got a lot of developers, but I would phrase it as going into maintenance mode. So there's a lot of new crazy stuff out there. There's 3D and WebGL and all that stuff, but that's kind of a whole nother pattern. And I think Leaflet isn't really interested in those things. So that doesn't mean it's irrelevant. I don't think it's going anywhere. It's been tremendously popular. I think people are going to continue to make Leaflet apps for a long time. I think it's a simple choice and it's the right choice for a lot of applications. But I wouldn't expect to see many features coming. If you look at Leaflet's changelog in the last year, it's a lot of, I mean, they're good bug fixes, stability stuff, bundler stuff, but you haven't seen a lot of new features or layer types go in. I don't think you're going to. And we're following that lead with Esri Leaflet's development as well. So all of the new sort of snazzy stuff like native 3D, rotating the map, using WebGL are things that we don't have answers for in Leaflet. I wrote a prototype vector tile plugin for Leaflet that tries to synchronize a WebGL layer and the rest of Leaflet, and it's pretty hacky. I would warn against using that in production. If it's something that you're interested in, it's something I think you should definitely consider using version 4X of the JavaScript API for, because it's got all that capability, and they've been making a lot of improvements. We have samples. If in the last year, I'd say Webpack has kind of become the most prominent bundler for app developers. Rollup is still what we use, and it's something that's commonly used by library maintainers. But we have some samples for both. People are using both. Browserify is still out there too, even though Webpack's more popular. So you can check out these samples to see how to use some of the modern tooling with Leaflet, and that's an easy thing to do. They all integrate nicely and play nicely. It's one of the reasons why we initially developed Esri Leaflet. But the JavaScript API at 4X, especially with things like Esri Loader, they've made significant strides to make it a lot easier to integrate modern tooling with the JavaScript API. We've got samples that use Webpack, and with Dojo 2 coming around the corner, it's just going to be easier. So whether you're using TypeScript or you're using Webpack or not, there's a lot less idiosyncrasies to getting the JavaScript API to play nicely, and using tools like Esri Loader allow you to integrate with frameworks like Ember, that have had a lot of opinions that clash with the opinions of the JavaScript API. So we're in a lot better position than we've ever been before to ship apps with the JavaScript API that are small, they're lightweight, they use modern tools. A lot of folks historically kind of leaned on Leaflet thinking that it'd be easier to get started, and that's becoming less true by the day. So I would definitely encourage you to check out these samples. And as the 4X API gets more mature, there's a lot of great stuff there, a lot of improvements to the design, and good reasons to use it. So I'd think about that pretty seriously. I'll take questions now, but I am always interested in surveys. Criticism is welcome. I tried to hit some intro stuff and some advanced stuff, and based on the audience was good, but you can do a simple vote with a survey and say, I wanted it to be more advanced, or I wanted it to be more basic, and whoever wins that vote, that'll kind of determine how we go next year. Either way, thanks for coming bright and early on a Friday morning of the conference. I hope you guys are having fun and getting a lot out of it. I've been having fun talking to all of you. So that's it.